The first experiment will be the glow-in-the-dark Mentos geyser.
Glow-in-the-dark Mentos Tonic versus Diet Coke. Tonic water allowed for the classic Diet Coke and Mentos eruption when an added glow-in-the-dark effect. But which beverage would actually produce a bigger eruption? The beverage is actually arbitrary. The real decided is diet or not. Multiple entities facilitate the reaction, but chief among them is a more abundant sugar or sweetener in the beverage. These sugars act as a surfactant, but lessen the work required to create a bubble, allowing for more to be created, and hence a bigger eruption. The commonly used zero-calorie sweetener, as part meat, is a more effective surfactant and comes paired with a preservative that also aids the process. Therefore, for the biggest explosion you want, the diet option.
This next experiment is sure to rattle your bones as we turn up the heat with color fire.
Color fire concentration. When we add different metallic salts to a flame, there is a change in the color of the flame. What would happen if we were to increase the concentration of those salts? As the coloration occurs from the excitement of the atoms raising electrons to higher orbits and their return back to their original orbits, concentration affects the flame directly to an extent. When very low concentrations of the metallic salt are introduced into the flame, the coloration is spotty, and upon close observation you can see that many of the rising flames are still clear. But when a sufficient concentration has been introduced for the flame to interact with, there is normal repair and change. In other words, it has reached the threshold.
Just remember that no one would believe you if you said you saw a ghost.
Ghost rockets. Why did we see some rockets fly all the way to the ceiling while others were unable to leave the table? The rockets work similar to a hot air balloon, off of Z convection currents. As the flames move down the cylinder, they heat the air in the cylinder, creating a density difference between the inside and outside of the cylinder. This causes the air inside to rise and cooler air to fill the space it once occupied, creating a net upward force. Unlike the hot air balloon, the tea bag also burns down to light an ash frame, lessening the total mass. This system fails when the flames burn down the cylinder unequally. When this occurs, the force from the convection current is uneven, leading to the force acting non-vertically.
In our next experiment, we will suffocate flames.
Dry ice candle gas chamber. As the dry ice in the fish tank continually sublimated, the more dense carbon dioxide began to fill the tank, continually climbing to suffocate the flames. This all occurred in stagnation with no airflow. So what would have happened if there were to be airflow? As a fluid, the gases in the fish tank would be highly susceptible to any force. Say your hand briskly brushing by. This could cause the carbon dioxide to act like water in a fishbowl and in a sense slush out the tank. Without this inhibitor present at the site of the reaction, the flame would have all the necessary reactants to continue burning and would do so while the dry ice continued sublimating, and the resulting CO2 gas was whisked away.
For our last experiment, we will summon a fire tornado.
The flame tornado. If we were to change the flame tornado removing the wire screen, what would happen? Nothing. The screen is vital because it allows for the spinning motion of the turntable to produce an angular momentum in the relatively cold air around the flame. When this is coupled with the hot rising air of the burning cotton balls convection current, we see the vortex effect of the flame tornado.
Take a closer look at that snout.